Hello again. I am just going to go through the final video for Unit 4 on trigonometry of right triangles. This section, the 4.2 section, is going to focus on more complex problems, real-world problems, and problems that involve numerous triangles that may or may not be attached in some sort of way, as well as some other shapes. And so in some cases, we do have the diagrams drawn for us, and in other cases, we do have to draw the diagram itself. So just going to go ahead and jump into a few of the examples. I won't do the examples that are done for you. Please have a read through those and just kind of make some sense of that. Preferably probably after you've seen some examples, because it will make those ones make more sense. So I jumped to page 215, and it's number 1 that I'm going to look at. So this one in particular, we are needing to find x. So in this case, we have one side, one angle, but that's not going to necessarily help us find the entire value here. Okay, so we have a couple of options. One thing that I would say is we need to find one other thing that happens to be on this triangle that is attached, something that is common. So in this case, if we had a common side, that would really help us out. So once I have that side and I have an angle, then I would be able to find my other side there. So let's go ahead to find that. There is a little piece of information hidden in this question that I do know that it may not seem like I know yet. So I know two angles, 90 degrees, 37 degrees. I can easily find that third angle in the big triangle. So to do that, I'm just going to go 180, take away 90, take away 37. Well, that equals 53 degrees. So I know that this angle up here is 53 degrees. Okay, and then once I have that, I am going to go ahead and use that angle to find this side. So if I know a side and an angle and I'm trying to find a side, then I can use one of my trig functions. So let's start off with, I'm just going to call this side A. So I've got, that's an opposite. This is my hypotenuse. Okay, so hypotenuse, and in this case, this is my opposite. So I'm going to use that trig function. If we go back to here, the one that uses opposite and hypotenuse happens to be this one here. Even though one of them is unknown, that's okay. I do know the angle there. So we're going to use that. So it's going to be my opposite. I still like to set them up this way and then readjust. My opposite we called A over 4.9. So that just means that I'm taking that 4.9, timesing it by the sine 53. On my calculator, as I mentioned in the last video, it depends on your calculator. You may need to go 53 sine and then times it by the 4.9. But you may have a calculator that wants you to go sine 53 equals then 4.9, but you should be getting 3.9 in this case. Okay, so A is equal to 3.9. So that's 3.9. Now I know a side in this triangle. I know an angle in this triangle. So now that side is still my opposite, but this side over here is my adjacent. So I'm going to now use the tangent ratio because that uses opposite and adjacent. So tan 37 is equal to my opposite over my adjacent, which is x. In this type of setup, I need to switch my tan 37 and my x. So x is equal to 3.9 divided by tan 37. You could type in 37 tan, write it down, and then go back. In my case, I can just go 3.9 divided by, if I put in my 37 and then the tan, and then push equals. Okay, so I got 5.2. And always remembering our units. This was meters. Good. All right, we are going to move on to another question here. I did want to just talk briefly about question 3. Let's see if that focuses. Oh. Nope. There we go. All right, so we've got some better focus here. And what I'm needing to find out is h, x, and y. Okay, and I do know a lot of information on this smaller triangle. That triangle is going to be somewhat similar. However, in the angles portion of it, and I'll tell you why in just a second. So in order to find x, it would be helpful if I knew h, because x is going to be equal to h take away 8.6. Okay, but I don't know h yet. So let's go ahead and let's try and find h first. So what I do know is I do know an angle here is 53 degrees, and I do know my hypotenuse side. So I'm going to call this my opposite. This is my hypotenuse. So that tells me that I need to use sine. So sine of 53 is equal to my opposite, which is h, divided by my hypotenuse. Okay, and now that I have that, I'm just going to bring this out front and multiply it. And you might be following the setup formula already. If you are, that's great. So now that I've got that set up and I've calculated it into my calculator, I get 17.1 is equal to h, and that was centimeters. So that's one part of my question. Now that I have that, to find x, going back to that what I had said before, 17.1 take away 8.6 will equal x. So that's 8.5 centimeters. So now I have one piece of information in this triangle. Now, this angle here, 53, is also going to equal 53 right here. And the reason for that is because we have a straight line. We know that right in here is a right angle. So if I go find out my angle up here in this triangle, 3 angles all add up to be 180. That's going to be 37. So if I know this is 37, then 37 and 90 taken away from 180 is going to make this 53. And then also if I think about this as one big right triangle, 53 and 90 taken away from 180, I know that angle as well. So now I know that the angles in this triangle and that triangle are identical. Now that I know a side and one of these angles, we can use that. I'm going to go ahead and use the angle 37. So I'm going to call this my adjacent and this my hypotenuse. No, I'm not going to call that the hypotenuse. I'm going to call that my opposite. Sorry about that. And adjacent. So now we're going to use tangent. Oh, my apologies. We're going to use tangent. So tan of 37 is equal to my opposite, which is y, over my adjacent, which is 8.5. Again, bring that out front. And do my calculation. Y is equal to 6.4 centimeters. So now I have all three bits of information. All right, moving on. This one happens to have a flagpole. You do have two triangles where it's just reaching to separate heights. It's kind of similar. Also keeping in mind we've got an angle of elevation, an angle of depression. But I am going to look at this number 5 because I wanted to look at one that didn't have a diagram drawn for you. So let's look at number 5. So it says an extension ladder must be used at an angle of elevation of 65 degrees at its shortest length. It is 18 feet long, fully extended. It has 32 feet. So I'm just going to draw a little diagram over here. So it has to keep an angle of 65 degrees with the ground. So when it's short, it only goes up to 18 feet. Then if I extend that at that same angle, it reaches to 32 feet. Sorry. And so it says how much higher up a building will it reach? Nope. Going back. Made a mistake. Sorry about that. Let's try this again. So as we're going up, the ladder happens to be 18. Then it doubles to reach 32. So hopefully that helps there. Like I said, we're just doing this for at-home learning, so I am not going to edit the video, but just show my mistake because I am a real person. And so we've got 32, 18 just to here. And it's wondering, what is the difference between this height and this height? So let's just maybe give that an X, that a Y. And so we're going to try and find out what Y take away X is. All right, so we need to find X. That is my opposite. And here it gives me my hypotenuse. So again, if I go back to my formulas, the one that uses the opposite and hypotenuse is sine. And I happen to be looking for my opposite. So if I want, I can set it up like this. Opposite is equal to my hypotenuse times sine of 65. Okay, if you'd rather go sine 65 is equal to opposite over hypotenuse first, and then know that you have to multiply that 18 by sine 65. That's cool too. All right, so when I calculate all of that, I get X is equal to 16.3. Okay, and that's feet. Now when I do y, that's also an opposite. It's opposite of angle 65. And my hypotenuse now is 32. So I can go ahead and use sine again. Sine 65 is equal to y over 32. Or rewrite this as 32 times sine 65 equals y. Therefore, y is going to equal 29 feet. So in the end, 29 feet take away 16.3 feet will get me my answer, and that is 12.7 feet difference. So there's a 12.7 feet difference in between there. Now, just looking at that lower question, how much further from the house must the base be when it is fully extended? So in order to maintain that degree, that 65-degree angle, it's wondering how much further away does the ladder now have to be from the base of the house. So let's go ahead and calculate that. In this case, I'm using my adjacent, so I'm almost kind of finding adjacent and the full amount, right? So let's go ahead. We're going to find, B is like all of that. And then we're going to do some subtraction as well. So let's use adjacent uses cosine. So we're going to say cosine of 65 is equal to A over 18, my hypotenuse. Change that around if you'd like. Which equals 7.6 feet. Now I'm going to do that with the larger triangle, using the full bottom as my adjacent. You could use tan at this point, using those sides that you had found in the previous part. I usually caution, if you had made a mistake, then you're going to make a mistake everywhere. So I try to, as much as possible, use what is given if I can. So now we're going to find B over 32. 32 times cos 65. And B is 13.5 feet. So in the end, 13.5 take away 7.6 is going to be equal to 5.9. Oh, sorry about that. 5.9 feet. All right, moving along. The next example that I wanted to do, actually I did want to just touch on this one for a quick moment. So it's kind of like you've got a rod or a pole or something like that, and they put it in a big rectangular box because they didn't have like a long narrow box that they could just ship it in. So this just happens to be the box that they had. So in order to do that, they found a box, and it's going to go from corner to corner. And so in this case, they were looking for what is the angle does this make with the bottom of the box. So there are a couple of triangles involved here. In this one in particular, you can go through the example yourself. This one in particular, it has a right triangle with the base of the box. So the bottom of the box makes a right triangle. So your right angle happens to be right there in the corner. And then they use this diagonal that goes along the base of the box, which was your hypotenuse. They're now using as a leg with the side of, or the height of the box. So we're going to do some of those types of questions. Okay, so I'm just going to, you can go through this example on your own, because it has it written out for you. If you have any questions, please do reach out to me. But we are going to look at this question together. I really like this question because it's a navigation question. And so it does talk about an airplane is flying 100 kilometers north and 185 kilometers west. So if I'm going west and north, make my west just a little longer. So I've got a northwest type of situation going on. So here's my airport. Okay, here's my, nope, that's not my plane. But that's just like, if I'm drawing this on the ground, that's the northwest. So this is 185. This is 100 kilometers. Now, in addition to that, this plane is going to be in the air, straight up, 7 kilometers. So what I can do there is I can take and just draw another right triangle using my hypotenuse of my original triangle now as a leg of my second triangle. So my drawing doesn't look as 3D as I wish it did, but this is going to be 7. So let's just get rid of that little mark. That's going to be 7 kilometers in the air. So think about this as you've got flat ground and then something that is coming up. Okay? And so often with these types of questions, you're going to be using one of the hypotenuse of your first triangle to become a leg in your second triangle, usually. Okay, so what is the straight distance to the airport? So we're wondering, here's my plane. What is that distance that it's going to be here? In order to find that, I do need to first find some information about this distance. Okay, so I can go ahead and use Pythagoras theorem because I'm just looking for a third length and I already have 2 lengths. So I can go 100 squared plus 185 squared. I'll just type that in here. So that was 44,225, and then we are going to square root that, and I get 210.3. So this here is 210.3. But that's not exactly where my plane is. My plane also happens to be 7 kilometers in the air as well. So now I need to take both my legs again, go 7 kilometers plus 210.3 squared. Do that calculation. So I'm going to square that plus 7 squared, and then I'm going to square root. And here it's not that much different, it's 210.4, and that is kilometers. So this distance here is 210.4 kilometers. Now the second part of the question does say, what is the angle of elevation from the plane to the airport? So we're wondering this angle, that little angle with these measurements like the 210.3 and the 7. So now we can go ahead, we're finding an angle. You can either use your hypotenuse or you can use your adjacent. I'm going to go ahead and use the opposite and adjacent. So my opposite in this case happens to be the 7. My adjacent is the 210.3. I divide those and then go second function tan, and I get 1.9 degrees. So I'm going to finish off with that question. Of course, you are then going to do your practice your skills and then get in touch with me regarding your assessment assignments. So Gonna leave it at that. If you have any questions, please do reach out. Make sure you're asking questions in the chat, and I will get back to you either with pictures and things like that, okay? Take care.